Okay, we're going to start with the fish. Well, our class is called fish. That's how you create a class. It's called the parent class, in case you're wondering. It's also could be called the superclass, but parent, I think, looks better, sounds better. So a parent means that it can have many children. So we can have as many different types of fish as we want. Well, what sort of things are we going to have in our fish? We're going to have a first name. We're going to have a last name. We're going to have a skeleton and eyelids. I have no idea why. This is just whatever I was thinking of at the time. So we have this init thing. What does this init thing do? Does anybody remember what init does?
With a dictionary.
It's an initialization, and it's like a dictionary, but it's not really a dictionary. It's more like a list. But what does it do? Anybody remember what it does? When you create an object, there we are. When we create, for instance, a clownfish, we can create a clownfish with the name, first name. So this way we can put stuff into the object as we're creating it. And these guys are called attributes or properties. So a class does two things. It stores information. It does something. So the information that can be stored can be called attributes, properties. There's several names for it, and I'll go between them accidentally. But we can store these four items. We can pass in whatever name we want at the beginning. So I can make a clownfish called, where's the clownfish? There it is, called Casey. Now, when I pass in the clownfish called Casey, this is something we didn't talk about, I don't think, but these are called default values. So if I just pass in clownfish, automatically it's going to be fish, bone, and false. There are no eyelids on a clownfish. I have no idea if there's eyelids or not. And it's made out of bone. Yeah, I have no idea. This is not biologically correct. Without this, we have a blank object with nothing in it. And then we have to use what are called setters to set the information into the object. We use setters to put information into the object. We use getters to get information out. So we don't ever access these guys directly. And everything to do with the fish is in this class that's called encapsulation, like putting it in a capsule, like you might take cough medicine or something in a capsule. So everything having to do with the fish is in here. And this is actually an inheritance one, so we're not going to look any further at that. I need to find one that's a better one. Let's see. Person tutorial, person simple class, person main program. Okay, let's try this one. Oh yeah, there's a good one. So in this case, when I create a person class, notice I have nothing in here. I do not have an initialization. I create a blank object. And then for that object to store something, I have to set that information into it. So the information goes from here into the object, here into the object. And if I have Paul say hi, he is going to return a string with his name. And then that'll be printed out. And then I can also get his hair color. So I'm getting information with this. I don't have to get it. I can use we'll do something different later on. I just thought say hi was a pretty good one. But we're either getting information from the object or we're sending information into the object. And this does both. And there we go. So, yep. Hello, how are you? My name is Paul. My hair is brown. That's what's stored in the Paul object for about maybe 2 milliseconds. But then the program quits and everything's gone. The garbage collector comes along and says, I want my memory back. I want my memory back. And then you're good. So Python, when the program quits, it automatically says, let's take out the garbage. We're not going to have anything hanging around in memory to cause any trouble. Now we have the shark, which is always fun. And notice each of these methods, what's the same thing about each of these methods? What's in common with all of those methods? What things are in common? What things do all those methods have? Yeah, Hudson, go ahead.
They all have self in it.
Yep, what does self do?
Puts it in a class.
Yeah, puts it in the class, it ties it together, it holds it together, it says it belongs to the class. Belongs might be a good way to say it. What else is the same in here? What else is consistent about those guys? They all have a
Well,
definition that defines it. All we're doing in here is defining things. Nothing happens in a class when you create an object. Nothing happens until you call methods with the class, with the object. And this, because of the self, swim belongs to Sammy. Be awesome belongs to Sammy. Get name belongs to Sammy. That's what the self does. Each of these belong to Sammy. They're part of Sammy. And we can create a Ignacio, we can create a, oh, William's not here. Okay, we could create a Hudson. We can create whatever kind of fish we want. They can all have different properties, but the methods will all be the same, but they will be setting or getting different pieces of information. So far, so good? Yeah.
So, let's say we put the code of the definition and the class at the top of the code, and we started coding like 10,000 lines down. Could we still?
I would never do that.
Oh, okay. But it's just like an example to say, like, could we still call
Oh, yeah.
the class and all the definitions from?
Yep. And even Windows doesn't have 7,000 lines of code in one file. They have it spread out all over the place in separate files. Yeah.
Okay.
Which is what we're going to do next. Yeah, we'll go past this. CoinFlip. Yeah. CoinFlip has 2 different files. Good example of what you're saying. Yeah, if you have even a couple hundred lines in one file, it's time to change things. And I don't know if CoinFlip is in here. Nope, it's in another folder. Let me find CoinFlip. We can have the class and the code in the same file, but if you have a fairly decently sized program, it's going to get big very fast, and 7,000 would be way too many lines to go through and find things. So here is CoinFlip 1, here is the coin class, and here is the application all in the same space. Well, this is how we start, and we're importing random because we want to generate a random number because we are flipping a coin. So in this case, we're tossing the coin, 0 is heads, 1 is tails. So if the random integer between 0 and 1 is equal to 0, we get a heads. If it's not equal to 0, we get a tails because we only have 2 possible values, 0 or 1. Now, when this class is created, it automatically sets heads as the side up. Right? So now we go down in here, and here's how we know what it is. We return which side happens to be up. So we do coin 1, we toss it, right? We get either a heads or a tails, and then we get what the side up is. We make another coin, toss it. We make a third coin and toss it. There. Heads, tails, heads. Each time, each roll or flip has a 50% chance of being heads or tails. You'll see patterns, but each time is a separate incident. With Savannah, with her gambling, it was all about this, right? With her gambling habit.
It's not an addiction yet.
Not yet? Okay. Just making sure. Here's our same class again, right? Same exact class. Now we're defining a main function. Really, that's all the difference, except I'm tossing it 10 times. Can I toss a single object 10 times? You betcha. I can change the information that's stored in the object by flipping it. Each time it's going to have a different piece of information. I get that information, and then I toss it again. This little guy is a convention that some Python programmers use to mean I don't care what that value is, I'm not going to use it. It's just a counter. So it could be something else. Could be I is very common to use for a throwaway variable, meaning you're not going to use the value anywhere because you don't care what it is. So this one will be a little different, mostly because of the loop, and I defined a main function, which is a better way to structure a program in Python. There we go, tails, 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 heads, 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 tails. Over time, the distribution will be like this side, it'll be about like that, and then it goes down. It's like a bell curve. If you've done statistics or algebra or whatever. Yes, Ignacio?
Based on like, you telling us how tier was, made using instructions.
Mhm.
But we like, have a similar theory when it comes to something like this in terms of like making an animation and like using the results is like tails, 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 and then heads, heads, heads as instructions for something.
Yeah, when you flip it, you just have a display. You'd have a display method, and depending on what your coin side up with, you display it to head or a tails.
And then use
It could be an ASCII text. With this, you'd have a little ASCII of a coin, either heads or tails. You just put it after this. You'd say, display my coin dot side up, and then, probably actually, yeah. You could do a thing in the class. Oh, where's my class? Uh-oh, I lost my class. Where did it go?
I think I will.
So this is the same class, but now it's totally independent. I can use this coin flip class any program I want. I don't have to rewrite the code. All I have to do is import it, and then I can use all the methods from that class. Just as if we're in the same program. That's what you do. If you have multiple classes, they all have their own file. That way, if you have 7 programmers working on the project, they can each work on their own class independently. That's one reason for classes. And the other reason is something called single responsibility, which means it's easier to work on code if all this does is be a coin. If you're flipping dice, you might have a die.py, and all that does is flip dice. Then you know which is which. If you import die over here, you know it's a die. If you import coin, you know it's a coin. And yes, you can just put in your little ASCII thing in here. I just haven't done it. I mean, I didn't do it. Ooh, there we go. Yep, here's another example of using coin class. We're just flipping it differently.
Yeah, that's.
Yeah, each time it's 50%. But you notice it came up that time. But the next time. There. So random numbers in computers are not truly random because a computer is digital. It has to start someplace and it generates random numbers in not a random way. It's called pseudo-random numbers.
Was that why, like, for the existence of computers being alive, it'll always be hacked? Was there's always a way?
No. You can add in you have to add in a random input of some sort. Like, if you could get an analog signal in there that's never the same, that would start it out at a totally different thing. Sometimes you can use like the time and the clock. But to get truly random numbers is way more complicated than what we have in the program. For our purposes, it's random.
Like when the Wi-Fi, the iPhone changed the MAC address each time.
That's a randomization, yes. So each time it's different, which is why our Wi-Fi won't connect with it. I mean, it won't keep the information because it identifies each device uniquely with its MAC address, which theoretically is unique. And the iPhone put that on there as a way of obscuring who you are, meaning then it's going to be harder to figure out which phone is yours because your MAC address every time you connect is different, which is fine for security, but then it's not very convenient if you have to reconnect to the Wi-Fi every time. Has that worked better since we changed that setting?
Yes, it has actually.